A circle with centre C has this equation. Express this equation in this form. Write down the coordinates of the centre C and the radius of the circle. Sketch the circle. A line has equation y equals kx plus 6, where k is a constant. Show that the x coordinates of any points of intersection of the line and the circle satisfy this equation here. This equation then has equal roots. Show that 12k squared minus 7k minus 12 equals 0. Hence find the values of k for which the line is a tangent to the circle. So I've got the question in summary form here. The first thing to do, part A, is we need to write this equation in this form here. Okay, so let's have a look at that. I've already written down the equation here so that we can save a bit of time. So here then, what have we got? We've got x, half that, we'll get x plus 7. Half of 14 is 7, so we've got that squared. Y, half of minus 10 is minus 5, square that. Now this will, when we expand this bracket, we'll get the x squared, and then we'll get the 14x, won't we? But we'll get a plus 49, so let's get rid of that, minus 49 there. And then we'll also get a y squared, which is fine, minus the 10y, which is fine. We'll get a plus 25, so minus 25 there, to get rid of the plus 25 that pops out of this bracket when it's expanded. So that's these four terms taken care of. We've also got a plus 49 here. So we're nearly there. So that tells us then x plus 7 squared plus y minus 5 squared. Now this cancels with that, and move the 25 over. So we have our equation of the circle. So that's part A. Write down the coordinates of the centre and the radius of the circle for part B. The centre C is at minus 7 and 5, isn't it? And that's part 1 and part 2. The radius is the square root of 25, which is 5 units. So there's B. Now part C. Sketch the circle. So I'm going to do a quick sketch of this. Part C here. Just do a quick axis. And here, say. There. Let's just draw it in. So here's the y-axis. Here's the x. Here's the origin. The centre is at minus 7, 5. So I'm going to draw it here. And that's C. And I'm going to, because I got a digital pen, I'm going to use dashed lines. And the radius is 5. So it will come down and touch the axis down on the x-axis and go around like so. And because this is a digital pen, it's hard to draw. So I use dashed lines. And there's our circle in question. So there's part C, and we've sketched the circle. The centre was that, and the radius was 5, so let's just itemize the radius. And C is the coordinate here. Okay, that's good. The line y equals kx plus 6 cuts the circle. Show that this quadratic holds. So y equals kx plus 6. So this is part D. Here. Well, we've got x squared, and we're going to put this line y equals kx plus 6 in place of y. So it's plus kx plus 6, wasn't it? Y squared plus 14x minus 10 lots of y, which can be substituted as kx plus 6. So we're substituting the straight line into this circle to see where they meet. And we're getting an equation involving x plus the 49. Now if we look back at that equation then, we need to get the x squareds, the x's, and the constant term. So let's do that then. So here we've got x squareds there. This is k squared, x squared when we expand this bracket, plus 6 and another 6, so that's 12k lots of x, plus the 6 squared is 36, plus 14x, minus 10kx, minus 60, plus the 49, equals 0. So how many x squareds have we got then? Well, it's just this one and this one, so it's k squared plus 1. Plus the x's, we've got 12k there, plus 14 there. Lots of x's, so this is done, this is done, this is done, this is done. Oh, we've got a minus 10k here, so it's just going to be 2k, isn't it? Because it's 12k minus 10k is just 2k. Okay, that's that one done. And then the number minus 60 plus 49 is minus 11 equals 0. So let's just look back and see if we're anywhere near it. 2 needs to come out in 25. Ah, we've got a 36 here, so I didn't introduce that. So I better be careful there and take a 2 out as common. That should do it. So we get k squared plus 1, lots of x squareds, plus 2k plus 7 x's. Now we forgot to add on the 36 here. 36 take 11 is 25. So a little error there. Let's just correct it now. Fortunately we had to show that, so we didn't need to double check and find our error in another way. So there's our equation then for part D. Let's just double check that again. Yeah, that looks fine. This equation has equal roots, show that this equation holds and hence find k values. So this equation has one solution because it just touches the circle. So here, what have we got then? B squared equals B squared. Let's just have a look at what we've got. This is part D now. Part 2. Show that this, hence find k values. So this is part 2. B squared minus 4ac equals 0 gives, because that will be the condition for equal roots when they touch. B squared will be this whole thing squared, which will be 4k plus 7 squared minus 4 times a, k squared plus 1, times c, which is 25. So the 4's all the way through the equation in the first and second term cancel, and we get k squared here plus 14k's plus the 49 when we expand this bracket minus 25k squared, okay, minus 25, isn't it? So what have we got? We've got 25, k squared minus 25 is minus 24 k squared, plus 14k. 49 minus 25 is plus 24. Okay, so divide all the way through by 2 and run a minus through it. So divide that by minus 2, we'll get 12k squared. Divide this by minus 2, we get minus 7k. Divide this by minus 2, we get minus 12 equals 0. Is that what we needed to show? Let's just have a little look. Yep, that's what we needed to show. Hence find the k values. So there's our equation then. Now what does k equal? Not nice. So how would we factorize this? Well, I'm going to probably complete the square here on this. So what I'm going to do is give myself some room, and I'll just get rid of this stuff up here, and I use that to do the workings. So I'm just going to solve this equation by completing the square now. So I'm just getting rid of this part of the question and putting part 3 in here. Let's work on this now. Okay, so divide by 12, k squared minus 7k over 12 minus 1 equals 0. So that would be k minus 7 over 24. Wouldn't it? Half that value, and that's squared. And that would, and then we need a plus, then we need a minus 49 over 24 squared to counteract that comes out. Minus the 1 equals 0. So should we just use the formula? Probably best, isn't it? So let's just use the formula. That's awkward, and I can't factorize it, I don't think, although I'll try. Well, let's have a go at factorizing it then. So here, the 12k, I'm going to try 4 and 3. 4k and 3k. And on the other one, I'm going to try 4 and 3. Because the difference between 16 and 9 is 7, so that would need to be a 4 to make 16. This would need to be a 3 to make 9. And the difference would be 7. It's a minus, so the bigger would be minus and that would be plus. And that equals 0. So let's just check that. 12k squared minus 16 plus 9 is minus 7. And then plus times minus is a minus. 4 3s are 12. If you didn't work out the factors, you can complete the square, which is tedious, or you can use the formula, which is also tedious, of course. So here k is equal to minus 3/4, and here on the other one k is equal to 4/3. So there's our two values for k.